again, and welcome back to our tutorial series on how to create a custom sound engine using SuperCollider and Unity. So in this video, we're going to cover how to actually take the source files from the Unity project's audio assets folder and put them somewhere else on your computer that you can later then access through SuperCollider. So what you're going to need to do is find out where you originally saved the Unity project. In our example, we saved it in the user root folder. Once you find Unity's folder, you want to open it up and look for a folder called Roguelike. This is the project folder for the game we've been working on, and inside it is where you'll find the audio assets. So go to the Assets folder and then find Audio. This will contain all the sound effects as well as the music that is used in the game. Right now we have them all muted or turned off. We covered that in a previous tutorial, so Unity is not making any sound right now. So what you're going to want to do is copy all of these files and paste them into a folder on your desktop. You can name this folder anything that you like, but we'd recommend that you name it something that makes sense, something logical that will actually be of use when using it within the project. And keep in mind, you will need this name later when you go to script and file paths. Now that we've stored all of the audio assets from the Unity project remotely, we are ready to load all of the audio assets and music into buffers inside SuperCollider. And now that we have all of that set up, we need to actually create something called the synth-def that will handle all the audio playback of those samples. So the first thing you need to do is actually create the synth-def. If you type synth-def, this will create a new synthesizer on the server that we can then play all of our audio sounds through. First argument for the synth-def is the name of the synth-def. In this example, we're going to be using the name sampler. The next argument is the function, or what exactly will this synth-def do when we call it later on. Within this function, we need to set up a few arguments. Simply put, these are going to be various parameters that we will later use to kind of tweak and tune the function. So the first argument that we need is called out, and this will be used to direct the synth's output to a specific output bus in SuperCollider. We have it set to a value of 0, so this will direct the synth's output to the master output bus of SuperCollider. The next argument that we need is called rate, and this is an argument that will control the overall playback of audio, and with a value of 1, it will play forward at normal speed. The next argument is amp, or amplitude, and this is used to control the overall audio level when we're playing back our samples. We tend to leave this around a default of 0.5 or half as loud as it can be to safeguard against clipping or distortion, and if for some reason our code is broken, it will help protect our ears from any sort of overly loud sounds. The last argument is called buffer, and this is the actual location that the synth will be looking for its sound source. So the next thing that we need to do is set up a variable called signal. We are going to use this variable to create the sound source, or what exactly the synth is using to generate sound. In our example, we're using an object called a playBuff. This object will play audio that is loaded into a buffer through our sample synthesizer. The first argument of the playBuff is number of channels. So depending on your source audio, you're going to want to use a 1 for mono or a 2 for stereo. The next argument is the buffer number. This argument sets the audio stream that will be loaded into the buffer. In our example, we use the argument buffer, which we initialize to 0, but can be changed at any time throughout the function. The next argument can be a little complicated, but what it ultimately does is ensures that all audio will play back at SuperCollider's default sample rate, regardless of source sample rate. Once we have all of that set up, we need to add something to the function called the done action and set it to a value of 2. What this is going to do is once the sampler finishes playing an audio file and it drops to silence, it will free the synth or terminate the synth from the server. We do this so we don't accumulate synths on the server, and this will help to free up computer processing power. The last thing that we need to do is add an out.ar. This is used to route our sample playback to a specific bus. If we don't do this, no audio will be passed out of the playBuff. Earlier in this function, we created an out argument and set it equal to 0. So for the first argument of the out.ar, we will use out. Because this is set to 0, it will route audio to SuperCollider's master bus. The next argument is the audio source that we are trying to output. Above, we set our audio source equal to a variable called signal. So in the out.ar's second argument, you want to use the word signal. Now, to ensure that we have amplitude control over our audio output, we multiplied signal by our argument called amp. So anytime we change the value of amp, it will actually multiply the signal by that value and either boost it or attenuate it depending on which values we're using. The last thing that you need to do after setting up all of that is to add the synth to the server. Whenever you run this entire block of code, it should show that a new synth has been added to the server through SuperCollider's post window. Now that we have all of our samplers created, we need to create a variable that we'll use to load our audio files into their own buffer streams. So we're going to create an environmental variable called foodvar in this example and set it equal to buff.read. This will create a buffer, allocate memory for it, and then load the audio file into it. The first argument is the server we want the buffer to be created on. For this, we will use the default server. The next argument is the file path for our desired audio file. Now that we have the sound effect for our food pickup loaded into the variable foodvar, we need to make sure that that variable is being called within the OSC definition for food pickup. What we need to do is go down to the OSC definition for food, and within its function, call the synthesizer sampler and make sure that it is playing the audio file that has been loaded into the foodvar buffer. To do this, we need to add a couple of lines of code to the OSC definition's function argument. You're going to want to type out synth, and then within its arguments type sampler so it knows to call the sampler synth. The second argument is an array of parameters that will be used to load the sound effect that is stored in the foodvar variable into the buffer that is being played through the sampler synth. Once this is all set up, whenever we receive OSC messages for food pickup, the synth will be called, the buffer will be loaded, and it will play the sound effect for food pickup that is loaded into foodvar.
You want to make sure that the server is booted, and sometimes you get ghost synths that are lingering around and it won't allow you to boot the server. So you go into your activity monitor, find the synth, and what you basically want to do is terminate the synth. So when you go back to SuperCollider, then you can reboot the server, and after the server's rebooted, the numbers at the bottom right will turn green, and it will allow you to go ahead and run the bit of code we've wrote here. So select it all, press command and return, run it, and then go back to Unity. And when you play the game, it will send a message when you gather the food. And there it is. So to complete this project, what you want to do is create a variable for each instance of sound that we've already kind of written. So do one for soda, chop, game over, all of the OSC defs that we've already made. Create a variable for each one of those and set the destination for each one, and then put that into the OSC def accordingly. We're going to be doing another tutorial on how to do that soon, but we wanted to just get this up here for you. All right, thanks for watching.